Look really closely. Now the change of the volume we can get geometrically. Which is nothing but B into dH, which is actually the area. Now area into distance, that becomes volume. Now B, the change, if the discharge is changing for a constant width, the height will be changing. It must need to change. So in order to define that, we will define the change del H by del T into dt. For how much distance it is changing? It is nothing but dx. Okay? Is that clear? So according to the mass of conservation in open channel flow or continuity equation, we can write that these two terms equate each other. So if we equate these two terms, so we get minus del q del x dx dt equal to that B into dH part here, which is automatically becomes the change of the cross sectional area. Isn't it? So now we can cancel out these two terms. So we can write del q del x plus del t equal to 0, which will be our continuity equation for a general rectangular open channel. Now if we introduce a velocity and several geometrical channels in that equation, so what it becomes? That Q equal to V into A. Now if we derive that V del A del x plus A del V del x plus that term will be our V into del H del V. This, now what we know, that the hydraulic depth equal to A by B, isn't it? Put that term here, we get if we divide the whole thing by B, we get an equation like this. If we consider the velocity and also the hydraulic depth, that thing becomes our hydraulic depth. Now this is for the continuity, this is the continuity equation, mainly the general continuity equation for open channel. In that case, we can say del q by del x equal to 0 for steady flow, del q by del x not equal to 0 for unsteady flow. Now that was all for understanding the conservation of mass equation for an open channel flow. Now, the energy. Listen very carefully. Now, think of an open channel first. This is the surface of the open channel. Now say this is the slope of the channel. Okay? This is the slope of the channel. This is the theta we get. Now this is the water surface. And that red color thing which is become our datum, level. This is our slope, this is our water surface. Now if we think of the energy, let's say divide it by two parts, two section to understand it. Now in industry or in academic, when we talk about energy, we talk about energy per unit weight, which is called the head of the flow, which is an indicator of the total energy of the flow. Now for understanding the energy equation, energy in a flowing fluid that can be stored in the flow in three ways. One is potential, the second one is due to pressure, and the third one is due to velocity. Now I will discuss the mathematical and second part of this in the next lecture. For potential, if there is a particle, if we need to replace it in this section or this bed, how much work done we need to do on this, which is mg into z. Now when we consider about the head, then our potential head, which is become mgz by mg, which is z. Now think of a particle here, think of a column in that section, think of a column. Now if the flow is acting towards the column, there is a force on the cross-sectional area of the column. Now due to that pressure, that thing, due to the existing pressure gradient, that thing will act or gain an energy which is called pressure energy. Now in order to define that, how much energy it will need to lose to get in that flow, which is mgh. Now if we talk about the head here, so our head, pressure head becomes mgh by mg, which is nothing but h. This is our potential head, this is our pressure head. Now the velocity part, when the flow is fluid is flowing it must have a velocity, and due to the velocity, it must have a kinetic energy. From law of physics, we know the value is half mv square.